Hello, ladies and gentlemen. You are welcome to this free webinar on basic econometrics using R. It's quite a while. My name is Joshua. I'm going to be your host on this webinar. Let me start by thanking you for giving me this opportunity to share what I know about basic econometrics and to introduce the course. This is just part one. Hope we are going to have quite a lot of time together so that we are going to have a very deep understanding of econometrics and how to use R to carry out various econometric analysis. So again, I say welcome. What is econometrics? It's the application of statistical and mathematical techniques to test hypotheses and estimate relationships in economics. So basically, three different disciplines are involved anytime you are trying to carry out econometric analysis. We have the economic theory, that is if you are in economics, because it has found application in various other fields with their different theories too. But whatever be your field, other disciplines that are very essential in econometrics are the statistics and mathematical methods. Usually you translate your theories into mathematical equations or symbols. That is the mathematical model. That's why it's called model. And since your model will have some parameters to be estimated, then you use statistical methods in order to carry out the estimation. It has found application beyond economics. In finance, for instance, econometrics is being used for asset pricing, risk management analysis, and forecasting. In health sciences, it's been used to ascertain effectiveness of various treatment drugs, to assess various policy such as health insurance, in epidemiology, cost-benefit analysis, and several other health sciences area of specialization. In education research, it's been used for impact evaluation, assessment of various programs, and in estimating drivers of returns to education. Political scientists have found it very useful also in analysis of voting behavior in various political policies, assessing their impacts, and looking at drivers of conflict and wars. In environmental studies, it's been used to estimate the effect of pollution, valuation of ecosystem, assessment of climate change impacts, and a lot more. In marketing and business analytics, it's been used to assess the demand and supply side analysis. We have demand forecasting, for instance, estimation of price elasticities, conduct of various market research, and effectiveness of various advertisements means. In agriculture, it's been used for crop yield modeling and forecasting, and assessment of various agricultural policies, analysis of agricultural risk. In urban and regional planning, econometrics have been used for housing, market analysis, transportation studies, city growth modeling, and so on. Regardless of your field, what I'm just driving at is that econometrics is a useful tool in any form, in any field where relationships matter. So what are the functions of econometrics? Number one, since econometrics starts with the theory, so you have a theoretical framework for what you are trying to do. And for every theory translated into model, you have parameters to be estimated. So the first function of econometrics is to ensure that we have values for the unknown parameters. Then econometrics is used to test theories. For some people have defined it as test of theories to actually find out whether the relationship truly exists. Because the relationship may exist in certain region, but in certain region, it may be a different ballgame. We use econometrics to estimate models. And after estimating the models, we use the model to predict future behavior and to assess uh, policy, policy and programs. That is to look at how policy and programs affect diverse outcomes. What are the various advantages of econometrics? Personally, to me, the most important advantage of econometrics is it allows us to base decision on data. The data may be historical data, experimental data, cross-section, but we have data, so we are talking based on facts, not just on guessworks or opinions. Econometrics allows us to measure the strength of the relationship and to determine the cause and effects, not just correlation. Decision support provides a scientific basis for business and government decisions. And like I've said before, econometrics can be applied across various fields. That's an important key advantage. So what are the various components of an econometric model? There are three different components. We have the model itself, which is an abstraction from reality. It's simplified representation of the real world relationship. Take, for instance, building of a house. The starting point is not buying blocks or trying to arrange maybe the foundation or whatever. The starting point is to get a plan, get a good architect to help you draw the plan so that we know what is going to take you. That is what is meant by model. So you simplify that mighty estate or that mighty town that you want to build into a very small picture. So that is what model is all about. For instance, we want to look at how rainfall drives yield, whether it decreases the yield or decreases the yield. So we may just look at a very small representation, have data on yield, have data on rainfall, then try to do the estimation and so on. When you have the model, that is when you translate the theoretical framework into mathematical form, the next thing is to ensure that you have data, that is real-world observations. You collect the data from people. And we have four different types. We have the experimental data, cross-sectional data, time series data, and panel data. The moment you have the data, then the next method is, the next component is the statistical methods, that is the estimation technique. What are you trying to use in order to define the relationship? And one of those methods is regression. We have two types of regression. We have the simple, in which case you are looking at the relationship between two quantitative variables. One dependent, whose values you are trying to determine, and the other one is independent, the one that you have estimated to be the predictor. Then we have multiple regression. That is a situation whereby you have more than two variables, one dependent and two or more independent variables. And simple or multiple linear regression, regression can either be linear or non-linear. Though the starting point is to look at simple linear regression, like I said, it's made up of two variables, one dependent and one independent. So symbolically, let's our y represent the dependent and our x the independent. So you have your y equals to a plus bx plus e. Y and x are the dependent and independent variables. A and b are parameters to be estimated. E is the error term. And please let us pay attention to what the error term means. Since we already have y and x from our observed real-life data. Yield is the error time because there are so many factors that presentation you have not captured. So error captures the unobserved influences, and it captures all your errors, including measurement errors. And the simplest form of model that you can fit is the linear function. And the primary purpose is to find the best fitting straight line that explain the relationship between your y and x. So this is what simple linear regression model is all about. You have the dependent, you have the independence. Then you have the intercept. The intercept is what the value of y would be in case you are not using x at all. That is if the coefficient of x is 0. And you have the random error term. In terms of the data, I told you we have model, we have the data. In terms of the data, when you are dealing with simple linear regression, you are just dealing with two variables. Take, for instance, let's say our interest is to look at how advertisement on TV drives sales of our products. So in that wise, let's say we have interviewed 10 people. So we have data from 10 people on their sales and how much they spend on advertisement on TV. The easiest method to illustrate the relationship is by the use of scatter diagram. Scatter diagram is two-dimensional graph, so where you have the y-axis and the x-axis. In our situation, our y may be sales, while our x will be the TV. So, and the various points that we have here are the various values. That is the value of y at certain value of x. So, and definitely the values will be scattered here and there. And we can now fit a kind of average function on the graph to show the relationship between that y and x. If we have done so, you will know that some of the points will lie above the line, some will lie below. Those that lie above, then it means that is positive error term. Those that lie below, they are negative error term. And if you are using large sample size, that is principle of large inertia, we believe that the mean value of the error term should be 0. It's an assumption, and we are coming to that later. So if you look at this error term, how do you capture error term? You already have your y, you have your x. You capture the error term by considering some assumptions. And these are the various assumptions. The first assumption is that the relationship between your x and y is linear. Then we believe that the error term is independent of your x, that is the independent variable. Then in case of situation whereby you have more than one independent variable, we don't expect any serious correlation to exist between the independent variables. Then in terms of the variance of the error, we believe it should be constant. That is what is called homoscedasticity. And we believe that error terms should not be correlated with each other. The errors must be normally distributed with means of 0 and constant variance. If any of these assumptions are seriously violated, the result of the model, let us say, may be misleading. Let us know if it can. But definitely we have to test some of these assumptions. And that will be for another day, actually, to look at how we test some of these assumptions. And in case of violation, what do we do, and so on and so forth, because that is the real aspect of applied econometrics. So still looking at scatter diagram, like I said, it's a graph that illustrates relationship between two quantitative variables. It shows 4 things. Number 1, whether relationship exists at all. Because if it's scattered there and there in a random way, it's actually showing there is no relationship. It's going to show us the strength of the relationship, whether it is linear, whether it is non-linear. It's going to show the direction, that is positive, negative, or no correlation. And it's going to show us the clusters. It's going to show whether we have outliers or any other patterns that exist. So basically, in terms of the feature, it's two-dimensional. Then you have your data points. Then you have the pattern. Then it shows the types of relationship. In terms of interpretation, where the point trend upward from left to right, it shows positive correlation, which means that as x increases, then your y increases. When the point trends downward, which it means as x increases, your y declines. And that is an example of negative correlation. When it is scattered randomly, as I said earlier, then it shows no correlation. When all the points align on a straight line, then we have perfect correlation. Then outliers are individual points that fall far from the general patterns. So in terms of application, we use scatter diagram to find relationship between quantitative variables and to test hypotheses about the correlations, to identify the patterns, and it helps us in diagnosing problems in processes. So what are the basic limitations of scatter diagram? Number one, it can only show relationship between two variables at a time, limiting their use in multivariate analysis. Number two, even if two variables are related, a scattergram does not prove that one causes the other. Causation is not implied in any way. Number three, with too many data points, scatter diagrams can become cluttered and difficult to read, as a typical example of overplotting. Number four, then we can have poor choices of axis scales, and that can distort our visual observation of the relationships. The next one, scattergrams require quantitative numerical data, so you don't use it for analysis of categorical data. The next limitation, some complex relationship might not be obvious unless further analysis like curve fitting is performed. So nonlinear relationship may be very difficult to detect. And lastly, outliers can mislead the interpretation, either exaggerating or hiding some real relationships. So in terms of the outcode for scatter diagram, we need two packages. We need ggplot2. ggplot2. If you don't have them, you have to install them. I will show you how to do that when we move to the practical aspect. You define the data, where we import it, we see the way it's done. You define the x-axis, you define the y coordinates, then you add the regression line, you add the label if you want, and if you want the color of the regression line not to be black, then you have to add the parameter. Then you add the regression line equation, then you add the R-square. So this is just what this is all about. And you may not need to memorize anything. I will show you how to go about it in order to get the codes. So if you have done the correct thing, you get something like this. And I will do more of the interpretation when we carry out the practical illustration. So for multiple regression is used to model the relationship between one dependent variable and two or more independent variables. So let's say we are not interested in TV advert alone. Let's say we want to add radio as well as newspaper. So we have x1, x2, x3 against our y. So that's a typical example of multiple regression. And if you want to undo it manually, you want to use your hand to calculate it, you use matrix method, but the computation is somehow difficult to handle because it involves a lot of calculation. So in terms of data, don't forget the procedure that I'm following. It's very, very simple to follow. Model data estimation. Model data estimation. Model data estimation. You know, by the time we're considering simple regression, that's what we did. Now to multiple, I'll show you the model, then the data. This is the nature of the data. In this case, we have not just TV, we have TV, radio, newspaper, then we have location. So, and in terms of the code, in this case, I'm trying to run about 3 different models. I run the simple one, in which case I just want to look at how TV affects sales. The function to run multiple regression in R is LM, linear model, LM. So, and I define my data. If I don't want TV alone, I add radio to it. I add newspaper, you can see. So I have TV alone, TV, radio, TV. So I have 3 different models. And after estimation, I have the list of my model. Then model summary, that is a package that will help us to produce the formatted table in a publication ready form. So this is what we need. And that should take us to how to implement this in R. And I want us to please pay attention. In R, it's always good to use hash to distinguish comments. That is what we normally do. So what I want to do is estimating regression model. I want to start with simple regression model. I want to start with scatter diagram. The starting point is trying to search your working directory. To search your working directory, please pay attention to what I'm going to do. You go to session here, session. If you look at it, you have new session, you have interrupt R, terminate R, restart R, then you have set working directory. So you click on set working directory, then you see choose directory. So directory is the folder where you have all your stuff, your data, sort of things that you want to use. And I'm using free webinar folder, that's my directory. So I open it. Good. So after setting my directory, I want to import the data I want to use. The data is hard.csv. So I click, you can see there file, plot, packages, app, viewer, presentation. So I click on file here. But then I click on that file, you can see clearly all the stuffs, all the files in that folder. So this is the data I want. So I said import. Good. So here, then you click import here. Beautiful. So let's go back to our code. All right, so here we are. In R, it is important that you understand what packages are. Packages are different software developed by people that can handle certain analysis. For instance, we want to plot a scattergram in a very neat way. We need just 2 packages. We need ggplotUBR, ggplot2. In case you do not have them, if you don't have them, you have to install them. To install, you go to Tools here. You click on Install Packages. And you will type here the package. Let's say GG. You see as I'm typing, is auto-completing. PBU, you can see. So, but since I have it, I'm not going to install. So if you don't have it, then install. After installation, it is stored in library. So anytime you want to use it, there just type library and put the package in brackets. So this is what we have done. So then you run it, just highlight and run. So those are the 2 packages. So to plot my graph, you see, I don't want you to be memorizing so many things. I'm so used to this because I've been doing some of these things for quite a long time. So what you need to do, go to the package, and this is ggplotUBR. click on it. This is documentation for package this. So what I need is GG scatter. So you go and look at GG scatter, GG scatter. So this is GG scatter. I click on this. So these are the usage. I start with the data. My data is the data that I imported, that is AD. Then on the data, my X is the TV, my Y is the sales. These are just the variables there we can. If you click on this, you can see TV, radio, newspaper, this is the sales. So let me come back here. So, and I said add regular. In case you don't want to go through all these usage thing, you can look at examples and begin with the examples. You can see these are various examples here. So very straightforward and easy to do. So, and I say, okay, please add the label. Label is equal to T. T, this T means true. Then if I need another line apart from black line for the red line, I will say add dot parameter. These are parameters. List color is equal to red. You can change the color. If I want blue, I will say blue. There is no any color. You can use gray. You can use purple. You can use pink. You can use Indian red. That's one. You can use light blue, whatever, sky blue. All those colors are there. Then after that, I say, please give me the regression line. This is the function for the regression line. Then give me the R square. This is the function for the R square. This is it. Then I said, okay, put the label where Y is equal to 21. By the time we plot it, I will show you the reason why I said that one. So let's plot it and see. Run. Good. So this is the graph. For instance, now let's go up. If I want the color to be green, I change it to green. Then I run it. You can see. So you can choose any color of your choice. But if you don't put any color there, it's going to give you black. The reason why I said label.y is equal to 21, I want this R squared, to be in 21A, in 2021. Because my equation is on top, which is around 22 or thereabouts. And see, so if you want it to be in front of 20, this is what I'm saying. I'll just say 20. So around. You can see. So it's clear. There is no big deal about it. So let us attempt to interpret this result, for instance. These are various points. So let's have it this way. All right. Y is equal to 7.3. This 7.3 is the intercept, which is equivalent to my sales when I do not advertise on TV. Now this X is TV. So if I do not advertise on TV, I will still have my sales to be 7.3. The coefficient of X is 0.047, which means that if I spend extra naira, we're using naira, on advertisement on TV, my sales will increase by 0.047, which is good for me. So if I want to advise people around that corner, I will say, okay, please, it will be better for you to spend money on TV adverts. It's straightforward. And if you look at the coefficient of determination, R square is 0.6. This is telling me that variation in my sales is explained by a 60% variation in my sales is explained by changes in my in the investment I make on TV advertisement, which is very, very high. So, and if you have it this way, you can move it to Microsoft Word. You want to do that, just click on export, click to clipboard, then copy plots. Then you take it to Microsoft Word, for instance. Let me paste it here. So, and you can see it. So you can click on it here. Sorry, then you drag. See, beautiful, super clear, super simple, super straightforward. All right, so let's go back to our. So that is that about scatter diagram. Okay, before we leave that place, if you look at this 4.9, for instance, an outlier. No. Now to multiple regression. For multiple regression, I told us that if you want to produce your results in a very neat table, you need model summary. And that is what we've used here. So you have three models. Model one is still simple regression. LM is the function for linear model. We have this as a function of TV. This is my data. In the second model, I add radio to it. In the third, I include TV, radio, and newspaper. It's just what I've done. So, and after doing that, I say, okay, give me the list of the model. Call model 1, model 1, model 2, model 2, model 3, model 3. Then I did that so that I'd be able to use summary model to move everything to Microsoft Word. In this situation, for instance, I say, okay, please start the relevant variables, that is, variables that are significant at 5% level. So let's run it. Just highlight from here to the end. Okay, so let me shift this so that we can see the result clearly. So you click on run. So now this is the model. So we have the results. So we can move this result, for instance. To move it, just copy, because this is in viewer mode. Just copy this, super clear, copy. Then take it to your Microsoft Word. So let's go back to Microsoft Word. Paste. Beautiful. So here is the results. Okay. Let me move this out of this place. Cut. Good. And let me move it to the bottom of, yeah, so paste. Good. So, and yeah, good. So if you look at it clearly, for model 1, the intercept 0.7.334 and statistically significant. TV 0.047, we've had it. For the second one, both TV and radio are okay. And if you look at the result, you can see that if I increase my investment in radio adverts by £1, you can see that it's even adding more to my sales than if I increase my adverts on TV, you can see. So in this case, it would be preferable for me to invest more on radio than on TV. Yeah, because it's actually adding more to my sales. Likewise, if you consider model 3, then you can look at the coefficient of determination to show whether should we add more variable. The more variable we add, the higher the adjusted R square, which is showing the coefficient of determination. So this is how to go about it. This is how to run the model. And this is how to move the model to Microsoft Word. Um, yeah, I think so. This is all about the first class that we had, basic econometrics with R, and we've tried to look at the definition, the advantages. We look at the various types. We look at simple regression. We look at the easiest way to illustrate simple regression, which is using scatter diagram. Then we try to estimate the model itself using the linear model and so on and so forth. And we considered various assumptions that are needed in order to capture um, the error term. But we have not tested them. Yes, we have this model, but we do not know whether the assumptions of the regression analysis are actually validated or not. And that will be our next line of action uh, when we meet, hopefully, by God's grace. So once again, I'm very grateful for your coming. I thank you. I wish you tremendous success in your various endeavors. Stay blessed. Thanks and thanks and thanks again.